Well, thank you so much for joining. Welcome to this session on OOP versus data-oriented programming, which one to choose. My name is Venkat Subramaniam. We'll talk a little bit about OOP. We'll talk about when it's a good opportunity to use it. We'll talk about when it may fall on its face, why we should maybe consider a different way to do things. And then we'll talk about the pros and cons, and then we'll wrap it up. Best time to ask questions or make comments is anytime you have a question or a comment. So please don't wait till the end. Anytime you have a question or a comment, just start speaking up, draw my attention. I'll be delighted to hear what you have to say. So let's talk about object-oriented programming. I remember way back in time spending my youth during the time when people were still debating about whether OOP is the right tool. We should use it, we shouldn't use it. And that was way back in the late 80s to early 90s. And then, of course, everything quieted out after that. People just jumped on the bandwagon. We started using OOP. We never really paused to question whether that's the right thing to do, which is okay. It's worked really well for us for the most part. But I would say the 4 pillars of object-oriented programming are abstraction. Well, abstraction is nothing new. We've had literature telling us, even as far back as people like Plato talking about abstraction. And so we do abstraction in everything we do as humans. That's how we stay sane. Without abstraction, we'll go crazy very quickly because we cannot handle the complexity of what's around us. Abstraction is how we deal with complexity in our lives, and so in programming as well. We also talk about encapsulation. Encapsulation, of course, allows us to focus on the what and not have to deal with the how. So we can focus on what a service provides and let the service decide the implementation so we can change the two sides independent of each other. Inheritance, I would argue, is the weakest link in object-oriented programming. Languages like Java and C# and C++, they force us to use inheritance. But languages like Python or JavaScript or Ruby and so many other languages don't care about inheritance per se. So I would argue inheritance is the weakest link when it comes to object-oriented programming. But to me, the more essence in OOP really is polymorphism, because polymorphism says the method you call is based on the runtime type of the reference rather than the compile time, so that gives us extensibility in our code. So most of the time when I'm doing OOP, I'm really focusing on leveraging the polymorphism benefit of OOP, and I think that's really the essence for me in terms of where I would like to leverage object-oriented programming. Let's talk about this a little bit with an example, if you will. So I have an order processor, extremely simple example so we can focus on the essence. So the order processor essentially says, I want to process order. Obviously, you'll have a lot of other details I'm not really focusing on here, but to process the order, I'm going to provide a credit card. So if I were to go to the process order function, how does that really look like? It takes a credit card, does some work, charges a credit card, does some more work. Again, minimalistic, just focusing on the essence. There are some problems with this approach, first of all, right? So the first is this is tightly coupled. So the process order and the order processor itself is tightly coupled to the credit card. This fails what's known as the open-closed principle. We could apply the dependency inversion principle here and to decouple this to provide extensibility in the code. So what would we typically do in this particular case? You might say, gosh, we want to support different payment methods, so you may want to not use a credit card directly. Maybe we'll use a payment method right there, and we'll call this as a payment method. Okay, so what are we going to do with the payment method? Maybe we will say this is the payment method, and then we'll call a pay method on the payment method. Maybe that's what we want to really do. So the question then is, what's payment method? We could say payment method is an interface, and I want to create this under the payments package. And the payments method is, as you can see, the interface we see here. What does the pay method actually do? Well, in this case, I could say the pay method is taking maybe amount in cents that I want to really pay for that particular service. Again, oversimplification at this point. You may have an error being returned. We may have other data that's being returned as part of this particular payment. but let's not worry about those details right now. So if I were to abstract out the payment method, now we can argue that the order processor is more extensible. So it no longer depends on the credit card, but instead it depends on the so-called payment method. But obviously, in this case, if I go to the credit card, we could then say the credit card, in this case, implements the payment method. And as a result, in this particular case, we would want to have the pay method implemented, which would take the place of the charge. But in this particular case, I'm going to just turn around and call the charge with the amounts in cents right now. Okay, so that's basically an implementation we could see. And we could then go back to this code. And again, this doesn't really have any effect on this particular code. It's going to do exactly what it did before, but the payment order is more extensible than it was a while ago. So what did we achieve with this particular solution? Well, what we achieved with this solution is that the order processor is extensible for different payment methods. So you might pay through a bank transfer. You may pay through other means that you want to pay through, but you don't have to modify the payment method or the order process order function. Now, I often say extensibility is a slippery slope. You should never say the code is extensible. You should always say the code is extensible for a particular purpose. Because we could give the impression to the business that somehow this code is extensible, and then one day they call us and say, well, the customer wants to split the payment across 3 payment methods, and the answer is oops, right? We cannot just roll over and support it without any change. So extensibility works within a range of what we want to provide, and we have to be really clear about it. So this code is extensible for any payment which follows the payment method interface for a single payment per transaction. That's basically all we are trying to provide. So I think we all can agree that OOP works really well in scenarios like this. And we have exploited this over and over in a lot of code we have written. And I'm not here to tell you that OOP sucks and don't use it. It's quite the opposite. I love OOP, and I think we should continue to use it for a variety of things we do. In fact, even though this talk is not related to it, that's a take I often have in terms of even mixing functional programming with object-oriented programming. I often don't try to put one against the other. An interplay of those makes really good sense. So having said that, that seems really a nice choice. We should continue to use code for doing similar things as we move forward. So I don't see really a problem at all. So end of story, let's move forward. But then, let's think about a slightly different problem, if you will, than the one we just saw in this case. So what I want to talk about next is a slightly different problem, if you will. Imagine we have a third-party set of classes. This is not your code. This is not within your ability to modify this code. This could be a library that you use from somebody else. They have provided, it could be an open source product, could be a closed library within your company. It doesn't matter. But the point is, this is not the code you can change, period, right? It's a third-party code. That's what you're going to be using. Well, this third-party code in this example has literally 3 things. It's got a trade, as you can see, which is an interface. It's got a buy, which implements the trade interface, as you see here. And it also has a sell, which also implements a trade interface. Clearly, that's still object-oriented, isn't it? You got an interface, you got 2 classes, that implement that interface. The only difference here is it's a third party. And we do this all the time. You're using libraries in your code. Libraries provide classes and interfaces, and you often use that in your code. So this is not an unseen situation, a very common day-to-day thing that we do. Okay, great. But your business analysts are telling you now that you have a trade, and in the trade, you can call a buy or a sell, and you can call a process trade. So if you call the process trade, what does the process trade actually do? The process trade is going to perform an operation on the trade. So we're going to say trade.perform. And as you can see in this case, the trade does have a perform method. And you can call the perform method and perform the trade on it. So that's still OOP, right? So everything is still good. But the business requirements tell us that when you perform a trade, before you perform a trade, you have to audit the trade. Now, typically, I would be interested in using something like an AOP in this case. So I can use aspects, and anywhere a perform is called, I can use a point cut, I can intercept the call, I can do some work. But if I were to go that route, I'm going to be spending the next 3 hours doing AOP here in front of you, and that's not going to help us in any way. So assume that we can intercept this in some other way in AOP, but to make it extremely trivial and simple, I decided to use an audit rules.audit, and we're going to pass the trade to it. So it doesn't have to be an explicit call. It can be intercepted, and you can do some operation. So it boils down to how do we implement this audit function in our code for auditing a trade. And there are different rules for auditing. For example, if a trade is a buy or a sell, but if the quantity is greater than 5,000, then I need to perform some rigorous auditing. If it is a sell, if it is more than 10,000 quantity, I got to perform some more auditing. But these rules can change over time as well, so I need to be able to perform these audits. That's what my business is telling me. So the question is, how can I implement that particular code? So here we are. So we have this audit method. It takes a trade, and we want to perform the audit for the sell and for the buy differently. So I am still interested in this concept of OOP. I want to use abstraction. I want to use encapsulation. I want to use polymorphism. I want to do all of that. So how do I go about doing this particular job here? So one thing that comes to my mind here is, hey, I've got an idea. Let's call this as trade audit, and we'll call it as a trade audit is equal to, and I'm going to somehow create a trade audit, right? So we'll say create, we'll say, a trade audit, and I don't know how to do that yet, and I'll pass the trade to it, so we could call a trade audit on it. Well, it seems like an interesting idea so far. Then what do? I can say trade audit dot audit, and I can do the trade on it, the one I'm interested in actually auditing. I can pass the trade to it, and I can ask it to do the audit on it. So until this point, I think we're in good control, isn't it? Because you got a trade audit on your hand, and you're telling the trade audit to perform audit on that particular trade. So that's great. So how do I really perform this trade audit? Well, let's take the first step here. So here's my trade audit. So I'm going to say my trade audit is an interface I'm going to create, and I'm going to create it under the clients for now. Let's just keep it there. And what does the trade audit actually do for us? It's going to have a function called audit that's going to perform the audit on the trade. So far, so good, isn't it? Okay, great. But then what do I need after the trade audit? Well, as you can imagine, this could be a sell or a buy, isn't it? So I'm going to do a buy trade audit, and this buy trade audit in this case, well, let's do it this way just for a moment so we can actually get the code in place. I could say buy trade audit, and the buy trade audit may really be the one that is going to audit a trade, so we could create that one. So what is a buy trade audit going to look like? So I can create a buy trade audit, and the buy trade audit says, I'm going to provide a function called audit. What do I do in this audit function? I'm going to first of all say if the trade is an instance of buy, then do some work, and you can even use the recent feature for the instance of with the pattern matching syntax, and you can bring that in for the buy, if you will. So if it is, that's great. But if it is not, what am I going to do? Well, if it's not, we could say throw new, maybe an exception, unexpected, you could say, right? Expected, you could say a trade, because I'm a buy audit. How in the world you sneaked in a trade which is not a buy, and that's going to fail, right? So now it's a buy. What am I going to do? then I can say if the by.quantity, maybe in this case, a get quantity that you're going to bring in, so by.quantity, pardon me, is greater than, and we had the description here as to what we want to do. If it's greater than 5,000, we want to perform an audit, right? So we could say if it's greater than 5,000, we could say, output, again, do the proper thing. So, invoke, rules to audit, right? So to audit the by. So you could provide the code for it and do whatever that you need to do in that place. Otherwise, you can keep moving on. Well, so far, so good. But that's not the end, isn't it? We want to also provide, similarly, a cell trade audit. So how would that look like? We can go back here. Here's my cell trade audit. And the cell trade audit, similarly, is going to be a class that implements the trade audit. And we can implement the audit function. And what are we going to do within that? Well, we are clearly saying, here is the audit function we are receiving. And if the audit function says it's a cell, and we can bring in the cell, and then we can say if the cell's quantity is greater than 10,000, we want to perform the audit for the cell. Otherwise, that's not what I was expecting, and we can throw an exception at that point, and we can move forward as well. So that's going to be our cell audit class. Now, once we finish that, we still need to worry about the create audit function, right? We haven't done that yet, but we can get to that in just a minute. So once we get in here, we can ask it to create the audit and then call the audit on it. And the beauty of this is the audit will take care of auditing a cell or a by separately. How do I provide the create audit function? Well, one thought that comes to my mind here is to say if I have a trade, we could say if a trade is an instance of by, maybe return a by a trade audit. And otherwise, we could say else if it is a, if it's a trade is a instance of a cell, then of course return a cell, audit. In this particular case, new cell trade audit. You could go that route. But if you go this route, how does that feel? Does it feel like a brilliant code? Is it something you'll put on the wall? Will you celebrate? Will you go home and show this to mom, right? And tell her, look, mom, what I did? Do you expect her to give a pat in the back? Not really, right? Would you put this on your resume, right? To a potential employer and say, look at the beautiful code I wrote, right? No, this fails the open-closed principle, isn't it? Because this is not extensible. If we add a new type of trade, we got to come back and change this code as well. You're not going to be really thrilled about it. So what you could do potentially is you could say, no, I want to make this code extensible. So you could come up with a brilliant idea. You could say, class name is equal to trade.getClass.get simple name. By the way, here's one rule I follow. Never trust a piece of code anywhere a word simple appears in it. Because that's how you know that it's going to get really complex very soon, right? So there is no complex idea than one that claims to be simple ever. So we have a class name given to us. Then what are we going to do? We want to really get the full class name and maybe a convention we decide to follow here. And in this particular case, we could say, they're all part of the client. So I could say a client, maybe in this case, put in here, a client dot, and then we could get the name. Then we could say, in this case, this is a class, right? So we could say class equal to, and we could say this could be the, a class dot for name, and this could be the class name we are interested in. And once you get the class, what you could do is you could say return class name dot get declared constructor dot new instance, and you could create the instance for it. Now, clearly, the compiler is not happy with this, so we say, okay, go ahead and add that exception right there, and add that exception right there as well. And now you can see those exceptions have to be handled. Well, this code is no longer simple as it was before, so now you have to surround that with a try catch or push that exception up there. And what are you going to do with that exception that you do? And you have to worry about that as well. So you could do all of this code and work on that. And with vengeance, it says that's not still enough. You got more exceptions to deal with. And so you're going to propagate that as well in this particular case. And we want to cast it down to a trade audit right there. But that's not enough. You have to really take the trade audit here and handle the one added exception as well. How does that feel, right? It's something more to celebrate, isn't it? So it keeps, oh, no, don't take a photo of that. My goodness. Oh, wow. You posted and somebody said, this is an idiot, right? So give me a second. Give me a second. Hang on. Okay, so don't do this. Now take the photo you want, right? Absolutely. So the point really is, you can see how this blows up on our face. Now, what do we do as programmers? This is the beauty of our field, right? When you write terrible code, how do you feel good about it? This is called euphemism, right? When you write a terrible code, you give it a nice name for a pattern for it. Now it becomes, after all, it's not bad, right? Anyone recognize what pattern we have been using here? A factory, awesome, one. There's more to it. What else? Adapter? A strategy pattern. What else? So think of how we solved the problem here. What we did is we created a trade audit, as you can see. And then we have potentially, in this case, a sell trade audit. Similarly, we have a buy trade audit. So we got these parallel hierarchy of classes. So there's a trade audit. There's a buy trade audit. There's a sell trade audit. Any pattern comes to mind? Visitor. Did somebody say visitor? Yeah, somebody said visitor very quietly, right? Absolutely. A visitor pattern. And somebody the other day also mentioned command pattern. This is one of the problems I've been having for 30 years. When I look at code and I look at a monster people created, and I look at that and say, why'd you do this? And they say, oh, I used a visitor pattern, as if that should make me feel better, right? So the question I want to ask you is, forget about pattern for a minute. How does that feel? Does it feel like awesome? Or does it feel like, what did we achieve with all this extra code? Does it feel lightweight? Or does it feel heavyweight? What's your thought? It feels heavy, isn't it? So have we ever written code like this before? We all have, right? Absolutely, we have. But don't get me wrong. There's benefits to everything we do, but developing software is about trade-offs. That's what it really is. It's all about trade-off. And there is always trade-off. And I know it's hard, but we got to drop our emotions a little bit. And the worst way to design software is to ask, which one do you like? This is not ice cream flavor to like, right? It doesn't matter what I like. The question I want to ask is, which seems to be more sensible to maintain is the question I want to ask. So to me, that seems really heavyweight. What are the benefits? Let's pros and cons always, right? Here's the benefit. The benefit is, if we introduce a new type of trade tomorrow, if that new trade is introduced, here's the benefit. I can simply come over to my code base. I will add one more class in here. We'll call it my new trade audit, which implements from trade audit. But the minute I implement it, I don't have to change any other code. That's the benefit, as long as it is in the package I expect it to be. So that's the benefit. That's probably the only benefit. So this code will be open-close principle compliant. The disadvantages, right? Let's start listing them a little bit. So what is the benefit? What is the pros and cons is the question we want to ask. So the benefit right now, right? Benefit is you could say the code is extensible to adding new type of trade. We simply, create, in this case, my new trade audit that implements a trade audit. And off we go. We don't, right, have to change, in this case, any other code. So there is definitely benefit to it. I'm not going to say there's no benefit. But what are the drawbacks? So the drawbacks are, first of all, one, the code, that is a lot of code. This is actually really good if you get paid by the number of lines of code you write, right? You can keep billing. But at some point, it's going to be hard to sleep in the night, right? So that's going to be like, gosh, that's a lot of code we had to write. That's the first problem. The second problem with this code is that if we do not write that extra class, right? So if we don't write that extra class when a new trade is added, that is, so extra class when a new trade is added, we do not get any compilation errors. That is another problem, right? So if you don't add that class, what's going to happen? At runtime, you're going to get a class not found exception. How cool that is. Not really, right? So you're not going to get a compilation error. So you need to be vigilant about it and know that a new class is added, and you better go add this class because the compiler is not going to support you because the compiler doesn't know what you're doing in this case. We hit that under reflection in this case. So that's another problem. The third problem with this code is, how do you explain what the code does to a business analyst? Poor guy, lady comes in and says, how does the code work? And you're like, that's what I'm trying to figure out. You shut up, right? That's the problem. Because you're trying to look through this code and you're trying to decipher. And imagine you're not the person who wrote this code and you are new to the team. This is a common thing I see all the time when I go to clients. I wish I can count the number of times I've heard this statement, right? I was here in London on a consulting project, and I looked at a terrible design. And I looked at their architect and I said, I'm really sorry, why'd you create it? And he gave the answer I hear every week when I go to client side. And his answer was golden. He said, Venkat, you have to know, they created this before I joined the company. Right? This is always, right? It's never us. They left it. On that day, I posted on social media, I said, technical debt is the gift we give to the future programmers. Because we create this and we leave. And somebody comes along, they look at this monster, and they're like shaking, right? It's like, why? And the beauty is, we never document this. So nobody understands why. So this is why I often say we're not software developers, we are software archaeologists. Because we look at this code and we say, there's got to be a reason they did this, which is worse, because we are fearful to change, because what if these people were accidentally actually smart, and they actually did a good job, and what if we're negating that effort, right? So to me, when I review code for my clients, I often ask them, why are you writing code like this? And shockingly, the answer I get is, oh, why? We wanted to follow the solid principles. And it breaks my heart when I hear that. Because I actually see a lot of bad code being written because people want to follow solid principles. Don't get me wrong. I'm not here to tell you solid principles are bad, don't use it. No, not at all. But I'm saying that any principle can be misused, and so can solid principles be misused. Similarly, any pattern can be misused. And so just because something is a principle, it doesn't mean we apply it everywhere. I've seen bad code being written in the name of solid principles. I've seen good code being written in the name of solid principles. So we need to evaluate on a case-by-case basis and ask the question, is it helping us or not? So in this example, I would say, when the class is third party, we don't have the ability to modify that code. You cannot add anything to trade. You cannot add anything to sell. but you want to be able to do things for an ad or a cell on your application side. How do we do that? Well, going the route of OOP, invariably I find creates much more verbose code than I'm really happy with. And so what is an alternative to consider? That's the point I want to make here, is that it's not a problem of OOP. It's a problem of us using in a situation. And I'm not a fan of building this parallel hierarchy. Because to me, the parallel hierarchy is too noisy, too cumbersome, and it's hard to reason about as well. So that's the exact point here. So the code, I would argue, is hard to reason about. You can also say that it also, you could argue, right? So maybe a fourth point, it also violates the dry principle in this case. Why? Because if you really look at the cell and if you look at the by, there is so much of redundant code between those two as well, where we keep checking for the type and then deciding what to do if it's not the type. So, and then you also make a spelling mistake like I did as well. So the point really is that it's too much of that effort to be really carrying through. Not a big fan of it. So what can we do instead of going this route is the question. And how could it solve some of the problems we mentioned? Let's see if we can address each of these problems. And again, keep in mind, that's what I want to emphasize really, really well. So both in life and programming, we do not choose things and walk away. We are compromising. We are evaluating trade-offs and choosing among the options, right? Options in comparison. So this is really the key point here is we don't get to choose things. This is true in life, and this is true in programming, is trade-offs. So to me, I am more effective in my design when I remove my emotion from the design, rather than saying, I'm a big fan of functional programming, I'm a big fan of object-oriented programming, I'm a big fan of this style of programming. Well, sorry, if I'm a big fan of something, that is called a bias I'm carrying towards something. Because when that's not the right choice, I'm clinging on to it and saying, no, that's the way I want to do it because I feel good about doing it that way. But instead, if I say, let's just drop our emotions from that, let's just jot down the pros and cons of it. And let's compare the solutions and decide which one may be better versus which one may be worse in a given situation. And it's not universal. And this is one of the reasons why I really like to prototype my code. So if I sit down and tell developers this is the right way to do, half of us are not convinced about it. But if we can quickly create a prototype and side by side compare the solutions, I think we have a better way to evaluate the trade-off rather than saying this is what I like and let's do it this way and not even look at an alternative. So I'm not here to tell you which is the right way, but I'm asking you to evaluate the trade-off. So let's take a look at the alternative in here. So what I'm going to do in this case is, rather than going this route, so we'll just keep that one line here, but let's go ahead and comment all of these other things out, and let's come back to this particular function right there, which is the audit function. So what am I going to do within the audit function? So within the audit function, and you can write code to the extent you want to write the code, and you don't have to write all the code in one place. You can call other functions as well. So you can say in here something along the lines of, maybe you can say a message is equal to a switch, and you can then say a trade, and this is basically where you're calling a switch expression. And when you call it with the switch expression, I'm going to simply display the message right here. And again, in reality, you might take this message and perform some kind of an auditing based on that message, or it could be a message, not a string, but a data structure that can help you to do other things. So, and you could even use polymorphism in that layer if it makes sense. So what am I going to do in the switch? I'm going to simply say default, a new runtime exception. Let's start with that first of all. So, throw let's say, new runtime exception, an unexpected, let's say, trade. We'll come back and address this in a few minutes. Let's not worry about that at the moment, at this instance in here, if you will. So with that said, what do I want to do with this particular switch? It's a switch expression does not have a result expression, so we'll come back and fix it. So I say in this case, I want to perform a case, and this is going to be a cell. Well, let's start with the buy. And it's a buy, and we could simply say, we could say audit, buy, and we'll just leave it at that for a minute. So we could do an auditing of the buy. But you can also go a step further with this. You could say in this particular case, you could say buy when buy.quantity, you could say, is greater than 5,000. You could then say in here, auditing, we'll call this as auditing, let's say, a large buy, and whatever that entitles it, right? Again, this is a silly example. I'm just illustrating the point in this particular case. Similarly, what you could do up here is that you could say, I want to take those two, and here is a cell I want to bring in. And in this case, the cell, and if the cell's quantity is greater than 10,000, I would then simply say auditing a large cell. And this could be a general cell where I don't have basically that amount of quantity. You could write some code for that as well. So with that said, you can write the code this way, and then you can perform whatever call you need to perform at the very end of this for that particular operation. So what's this going to provide for us? So in this case, we are, again, like I said, you don't have to really do all the work here. You could call other functions that could be part of a utility that you can call and say, here is a bunch of functions that do the auditing. I'm going to call those functions depending on which one I'm calling. You could potentially do that as well in your code. So nothing stops you from doing that, if you will. So with that said, how are we going to benefit from this? So if I were to go back to the code right here and execute it, well, both the solutions are going to do the job, and you can see it's doing the auditing of a large sale, and that's working as well. However, when you look at this particular code, there are some benefits already we can see. The first is, the first benefit you see is, let's just take these over. That was a lot of code. Now what do we have? So let's again go ahead and list the pros and cons of these approaches and see how this actually works. So this is about using the pattern, let's say, matching syntax. Well, in this particular case, we could say the benefits, right? Benefits. The first benefit is, you could say, not a lot of code. So this is actually much simpler. We're not specifying maybe a pattern name. Instead, it's a pattern matching that we are using, right? So in general, though, a pattern, I often say this. This is one of the things that I feel like, and that is the more pattern we use is a reflection of lack of capability of the language. So the more, I would argue, you could say the more capable a language, you could say, language becomes. And again, languages are not stagnant. Language like Java is evolving as well. So the more capable a language becomes, we would, I would say, rely less on patterns and more, I would say, on features of the language. So to me, I'm a big fan of the patterns disappearing into languages rather than applying patterns on top of languages. I feel that to be more natural in programming oftentimes. So as a result, I'm usually a bit more suspicious of patterns in general. So going back to this, not a lot of code, that's my very first observation in this case. Okay, so that's great, not a lot of code, but going back to this, if we do not write the extra class, when a new trait is added, we do not get any compilation errors. We didn't quite fix that problem just yet. but we can make some gains knowing this. So the code is working right now, but I want to improve this code already just a little bit for us to gain a little bit more. So I'm going to go back to this code, and now we can have a conversation with the third party. And this is not what you and I can change in the code, but with the evolution of Java, it would be really hard for people not to use some of the features, and you can have a conversation. You can submit a request to the library authors and say, hey, if you make some changes, your library will be really a lot better, isn't it, right? So what can we suggest here? Well, I could say, maybe in this case, we could say it's a sealed interface called trade. So what's a sealed interface or a sealed class? A sealed interface or a sealed class tells you that you are going to closely control the family of classes that can follow that hierarchy. So this gives you an ability for you to extend the hierarchy, but users of your code are allowed to only use your classes, but they cannot extend it. They cannot extend from the interface, but they can use the interface. So this library creator has a trade interface. As an external person, I can use the trade interface, but I cannot extend from the trade interface because it's sealed. So in this case, I can say it's a sealed interface trade, but this interface only permits a sell and a buy as well. So both the buy and the sell are the two interfaces it allows me to extend. So that's the first thing it specifies. Then I can go to the buy, and I can say this is a final buy, but while at it, I can say, well, it's a final class. Why? Because I don't want anyone to extend from this class any further. Well, there is something I can do even better, use a record. Why? Because records are final classes. So you cannot extend from a record. So rather than saying you have a final class, you can just turn that into a record. After all, it is just holding a data at this point. So I can say this is a buy in this particular case, and the buy essentially says I have a string ticker and I have an int quantity coming in. I can remove all that code right now, and so simply we can use the ticker and the quantity are the two components of that particular a record. So similarly, I can go to the cell, and I can simply say that is a record called cell. That takes a ticker, and that takes a quantity as well. And as a result, I can remove all that boilerplate code, and I can say that's a ticker, and that's a quantity as well that I'm going to bring in that I want to use. So now that we made the change, what is the benefit we're going to get? So if the third party goes through the change and gives us a version of it, then we can say, aha, here in this case, we can take the quantity, and similarly, we can take this quantity and work with it. And let's see if the code is still working before we make more changes to it. So we can run the code and see if it works. Seems like it. So then I can go back to this code and say, hey, wait a minute. But because it's a sealed, I don't have to write the default. Notice the compiler is no longer complaining that it's not a covered path, because your trade can only be a sell or a buy. It cannot be anything else. However, what if in the future we have a change in this particular case? So for example, if I were to, just as an example, go to the trade, and I'm going to add into the trade in here, let's copy the buy.java for a minute, pardon me, and I'm going to copy it to my new trade.java, right? So let's go ahead and take a look at my new trade in here. So what is a my new trade? What is it going to do in this particular case? Pardon me, let me pull that code again here. So I'm going to go ahead and copy over the code we just wrote here. So I'm going to say copy my buy to the my trade that I want to bring in here. So back here, we'll call this as my new trade. That's what I called it, right? But of course, I need to add that to my permit. But that's the job of the third party, and they could say my new trade in there. Well, the good news is the compiler immediately gives you an error. It says switch expression does not cover all possible input. And so clearly you get a compilation error if a new type were added in your code. So that's a benefit you get out of this as well. I'm going to get rid of that new class we wrote. It makes the point. So basically in this case, we can go back and look at the code, and we get a compilation error if it were not supporting it, as you can see in this particular case. So that's actually very powerful, as we can see in this particular case, right? So that's a benefit you get out of that. So given this, you also have the benefit that when, right, you could say, when new type is added, we clearly get a compilation error if we do not implement, in this case, right, implement the default. Now, just pause on that for a minute. Let's talk a bit more about it. So the question is, the compiler doesn't want you to implement the default. The question is, should we still implement the default, right? That's a question. The answer is absolutely not. And the reason is, if you implement the default, you are trying to predict what to do in the future. That usually is a problem waiting to happen, isn't it? But in this case, if you don't implement the default, you get a compilation error. You can actually have a conversation with your business and say, hey, looks like the library introduced a new class. What do we do to handle it? And they can help us to determine from the business point of view how it should be handled, right? After all, we are here to support the business, not to just cook up stuff on our own. The second benefit of this is, if you don't really write the default, and maybe we don't recompile this code for whatever reason, maybe another third party is calling into our code, what if this new class comes into picture? Well, the good news is, if you don't write a default, they write a default for you. And that default will throw an exception automatically. So if you're curious about it, you can actually take a look at it by looking at the bytecode, and you will see that it says, exception when the default, is triggered, and that way that's much safer. As a bonus, you can also make the code even more concise, right? So the code can be highly concise. And how is that? So let's take a look at how it can be. So now that we use a record, you got a little bonus here as well. So you can simply say by, and in this case, you can simply bring in the quantity, if you will, and as a result, you can simply say the quantity directly rather than having to really use the by if you don't care about it. So this is destructuring you can use for your records as well. So I'm saying I don't care about the ticker right now in this case, but invariably you might, and in this case you can provide the ticker, and then you say ticker, and then the quantity that's coming in, and then I can just check the quantity at that point. I can make use of it. Similarly for the cell, just to show you a difference here, I could simply say, here comes the ticker. You could say ticker, or you can give a different name called a symbol. It's up to you. And then you can say, in this case, a quantity as well. And then you can simply say when that quantity is greater than 10,000, do some work with it. So those are some variations of things you can call as well by using destructuring syntax. Now, so that's another benefit. So looking at the cons over here, there was a lot of code, a lot less code, compilation error. So clearly the compiler will tell you when that's not really right. It's easy to explain the code, right? I think we cannot argue about it. It is easy to reason about and explain the code as well. So that is definitely a benefit. The fifth benefit here in this particular case is that it is dry. You're not duplicating your effort for different types. Now, keep in mind, there is never, if somebody says everything is great, nothing is wrong, that is really terrible, right? So that means we have drank the Kool-Aid and we're not thinking clearly. There's always a trade-off. So what is the trade-off in this particular case? And the trade-off is the code is not automatically, right? Not easily, maybe easily maybe I will say not extensible for adding new types of trade without changing existing function. That is a drawback. I think we all should agree about it. However, I would argue, if I say, oh my gosh, that's terrible, that's a view I'm going to have. But then you ask the question, what's the cost? And I would argue the cost is extremely minimum. Because when the compiler tells you you need to handle, you know exactly where to handle it. And that code is a small amount of code you're going to write. So to me, the drawback is really minimum for the gains we have, and that's basically how we can select from. So to answer the question in this case, should we really, which one should we use? And my argument is we should really use both, right? And we should really use both, but we should use each one of them where they make sense. So to me, it makes sense to use OOP. It makes sense to use data-oriented programming, but they both coexist. And to us, the benefit is we have the tool on our hand, and we can put them to use where it makes really good sense. Hope that was useful. Thank you.